Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 50. Can you believe it? Lesson number 50 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Nano. I will need you to pour yourself a nice big mug of iced coffee. And I will need you to get ready to learn some cool new stuff. So let's go ahead and get out our Jetson Nano gear. And as you're getting out your Jetson Nano gear, as always, I want to give a shout out to you guys who are helping me out over at Patreon. Your help and encouragement keeps this great content coming. You guys who are not helping out yet, look down into the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to learn today. Because today is really an exciting lesson, and today is where we really get into the idea of deep learning and deep neural networks on the Jetson Nano. And so today we're going to kind of really start working more towards what real artificial intelligence is. So I should kind of give you a little bit of a background, a little bit of definition of words. A lot of times you hear about machine learning, artificial intelligence and machine learning, and kind of on the surface, machine learning can be something that's really a lot simpler. And a lot of times it'd be kind of what I would call curve fitting, that you could look at a whole bunch of data where, let's say that you looked at reaction rate as a function of temperature, and you have all this data and you kind of do some linear regression or some curve fitting. And then if you look at a certain temperature, you can kind of predict a reaction rate. And that's maybe a little bit of an oversimplification, but I think that a lot of machine learning could be thought of as sort of a straightforward linear regression or a straightforward curve fitting. Now, when we start talking about deep learning and we start talking about deep neural networks, in those cases, you're trying to build a network that is not sort of like a simple input and a simple output, but you're looking at a lot of things in between that are sort of supposed to kind of model what's going on in your head. Your head has neurons, and there's all these connections between the neurons, and it's not just the neuron, it's the connections between the neurons, and that would be kind of like a neural network of how your brain works. And then that's what we're trying to simulate when we are building a neural network or a deep neural network in the computer, or specifically in our case on the Jetson Nano. Now, if we're going to do deep learning and deep neural network, we have to have models, okay? And we have to use those models. And to have those models, there's really kind of two parts of it. There's the training of the model, and then once we have a trained model, there's using the model. And you could kind of think about our first look at this was really with our face recognition program, because we were training it on a set of faces. Then once that training was done, then we were using that model that we had developed to be able to look at a face and figure out who it was. And that was really kind of pretty much fun. But the problem with that is that was very, very specific towards faces and identifying specific people. And so that maybe was kind of starting to get into deep neural networks, but you got to think there's a lot more stuff in the world than just faces. And so if you're going to recognize more than just faces, you're going to have to kind of move to the next level. So what we're going to do today is we're going to kind of talk about, there's going to be two things that we're going to be doing moving forward. There are going to be a lot of things we do moving forward, but the next two things that we're going to be looking at is, first of all, the first and kind of simplest deep neural network or deep learning that we're going to do is called image recognition. And let me kind of define what image recognition is. Image recognition, you show the system a picture of something, and it recognizes it or identifies it. Okay, and this would be using a system or a model that we call ImageNet. Okay, because what you got to understand is within the context of what we are doing here and within the context of what normal people with normal equipment can do, really it's very easy for us to use a model that someone has developed, but it's very, very hard for us to develop a model on our own. And so what we're going to be doing is we are going to be using ImageNet models that people have already developed. And some of these models took years and years and years to develop, and probably millions and millions and bazillions of dollars. And so we're going to take advantage of those models that already exist. And so one of the first model sets we'll be using is ImageNet, and that will be for image recognition. Now, what do I mean by image recognition? Image recognition would be where you present the system with an object and it figures out what the object is based on its training model or its training set. And so like right now, if you look at the situation here, you've got a lot of different stuff. You'd see the microphone, the curtain, me, my shirt, my glasses. So it's really kind of complicated. So you would, I think for image recognition, try to give a simpler view. And so let's say that I switched it like this, and then I got things out of the way, and then I presented it with a coffee cup, okay, or a little pitcher, okay, a little picture of a pitcher, and try to give it an object in as simple of a context as you could, and then it figures out what it is. And that is what we call image recognition, and we do that with the ImageNet models, and that's what we're going to work on today. Now, much more complicated than that would be object detection. And what object detection is that, like, let's just say I took the camera and pointed it at the room, and then it figures out, oh, here's a chair, here's a desk, or if I had something like this, it would recognize me as a person, and then in front of me it would recognize the mouse. And so kind of image object detection does a couple of things. It looks at a complicated scene and recognizes all the things that it can identifies all the things that it can recognize. Also, object detection puts it in a space, so it gives you the location of the object that you were detecting. For the earlier example that I gave you with just image recognition, it doesn't tell me anything about where the teapot is. I think I'm going to call this a teapot. I was struggling for words earlier, but it didn't tell me anything about where the teapot was. It was just saying, okay, buddy, the thing that you put in the front of the camera was a teapot. So we will begin our journey into deep learning and deep neural networks today, and we will begin by doing image recognition, where we're going to use one of these trained models that already exist, and then we're going to use it for our benefit of identifying what objects are. So I will need you to call up our old friend Visual Studio. For those of you who might just be randomly finding this video, realize this is video number 50, and in video number 49 we installed the libraries and the utilities and the tools that would allow us to do deep learning. And so if you just have a Jetson Nano and just happen to this video, you've got to at least do the installations and so forth that were shown in video number 49. And I don't want my videos to be too long, so I kind of break them up like this. And so we have a nice new Visual Studio Code, and I am working today in our NVIDIA folder, and I am going to create a new file, and I am going to call it deep learning -1.py. And I know you probably can't see that, but you can name it and put it where you want. I'm calling it deep learning -1.py. Okay, we've got a fresh new Python file here, and I know that nothing makes you guys more angry than for me to be in front of what I am typing, so I will move out of your way, and I will try to be very mindful to not cover up anything that you need to see. So if we are going to do deep learning and machine learning and deep neural networks, we will need to import some libraries. And so the first thing we are going to import is the Jetson Inference Libraries. The Jetson Inference Libraries will allow us to do both image recognition and object detection. We will start today again with image recognition. We need to import jetson.utils. The utilities are what kind of let us interact with the camera and let us interact with the screen, and so those are important. I like to always, as we're going through this, a really big deal in this deep learning is frame rate. How fast can you do what you're doing, okay? And that depends on your hardware, and so it's great that we have a Jetson Nano. Some of this stuff would be very hard to do on a Raspberry Pi, would not be practical to do on a Raspberry Pi. We need those 128 or however many CUDA cores that we got down there to do this type of deep learning, and we've got to have the hardware. But even with the hardware, we've got to write the programs, and we've got to be mindful that we're doing it in such a way that we're taking advantage of that speed of that hardware down there. So I like to always do frames per second to see if we're doing the job that we're doing at a fast enough frame rate. So I will import time. Okay, we will need to set the width and the height of our displays. So I'm going to go ahead and say width is equal to 1280 and width is equal to 720. Now you can't just set this to random things because sometimes the cameras will only accept one or they will only accept certain specific allowed frame sizes, and so you can't set this to random things. I'm going to be looking today at the examples at both using the Raspberry Pi camera, and I'm also going to be using a webcam. And the reason I'm using 1280 by 720 is that is one of the resolutions that will work for both cameras, which makes it a little bit easier to go through this code. Okay, now let's see what I am going to do. There's two ways that we can do the cam, and I will do both of them. So now we've loaded our utilities. I'm going to create the camera object. So I'm going to say cam is equal to jetson.utils.gst. I think that's like GStreamer. We're going to make a GStreamer camera. Okay, and what we're going to want is we're going to want width, and then we're going to want height, and then we got to tell it which camera. Well, for the webcam, it's going to be /dev/video1. Now, I think that the webcam will probably always be video 1, but if for some reason, if you don't have a Raspberry Pi camera plugged in, I don't know, it might put the USB camera on video 0. So if video 1 doesn't work and you have a webcam, you might try video 0. If you have two webcams, then the next webcam would probably be at video 2. You kind of see how that works. This is really nice. This is very, very nice for the USB camera, but we might also want to, I'm going to copy that and paste it. We might also want to do the Raspberry Pi camera, and for the Raspberry Pi camera, you still have width and height, but you just tell it that it's camera 0. Now I have the old board, the old Jetson Nano board that has the one camera slot, and that camera is at, in single quotes, 0. It's camera 0. Now my guess would be, and I can't confirm this because I don't have the dual Raspberry Pi camera Jetson Nano, but I would think probably the other camera would most likely be 1 in this particular call. Okay, now let's start out by using the webcam. So I'm going to comment out this. You comment out the camera that you don't have, okay, and then you leave uncommented the camera that you do have. So we've got that done, and now we've got a camera created. So now I need to create a display. So I'm going to say display is equal to Jetson.utils again, and this time a GL display and an open close. Notice the uppercase D. Okay, you guys, I hope know that these uppercase lowercase are in fact very important. So we have created a camera now, and we created a display. Now what we need to do is we need to create our network, our deep learning network. And so I'm going to call mine net. You can call yours what you want, but net's a good one. And that's going to be Jetson.Inference. And again, today we will be doing image recognition. So we will be using the image net. Notice the uppercase N in image net. And then I've got to tell it which model we're going to use. And we are going to use today Google Net. And darn it, I should have had this called up already, but I'll kind of show you which ones. I'll try to show you which ones. Okay, what we are going to search on is we are going to search on Hello AI World Jetson Nano. And then you see that we've got 2 days to a demo NVIDIA developer. And then we have got AI World. So we're going to click on AI World. And then we're going to come down under AI World. And you can see that we have classifying images with ImageNet right there. Let's try to go there. And let's come down. And here are the networks, or the models, the pre-trained models that you can use. Now, in lesson number 49, we downloaded all of these models. So we are going to use GoogleNet. Okay, you can try all of these different ones because different ones will find different things, and some work better than others, and some work better for some things than others, and so you can play with all of these. But that is what goes right there, and if you followed along properly in lesson number 49, you will have all of those. That was a digression I did not mean to spend so much time on. Okay, but now we have created our display, we have created our network, and now I'm just going to grab the time. So I'm going to say time mark is equal to time. So this is just grabbing what the clock time is at the point that I'm going in this loop, and so I will use that in order to calculate frames per second. And then also I have to give it an initial frames per second filter. Frames per second filter is going to be equal to 0 because I'm going to have a low pass filter that's going to be smoothing out that frames per second. So I've got to kind of initialize it up here. Now we're going to go into our while loop, and we're going to say while display, that's what we just created up there, while that display is open. As long as it is open, we're going to be in this loop. Now when you kill the window, it will kill the program. So we are now in our loop, and what we need to do is we need to go out and grab our frame. And so we get frame, and then what this classifier, or what this frame grabber does is it returns 3 parameters. It returns the frame, it returns the width, and it returns the height. Okay, and it's important that we use this width and height because even though we gave it a width and height, in case it's giving us something different back, we've got to make sure that we use this width and height. Okay, so we've got width, comma, height, and then that is going to be equal to cam, that's the camera we created, and then capture RGBA. Now what you notice is that we are going to be working in RGBA as opposed to our old friend OpenCV, which used BGR. And this will cause us a little pain as we go through this, as you'll see later. Okay, so now I have a frame. What I want to do is I want to look at it and see if I can identify or recognize an image in the frame. So I will look for class ID, because this classifier doesn't return a word like teapot, it returns a number like 3, and then you've got to take the 3 and look it up on a list to see what classification goes with that class IDs. But we're going to get class ID, and then how confident are we? Confidence. So this call is going to return two things, class ID and confidence. And the call is net. That is the deep neural net that we set up above, net. Okay. Net dot, what are we going to do? We are going to classify. We are going to classify. And what do we have to send it? We have to send it the frame and the width and the height. And again, that is the width and height that's sent us. And the cam capture RGBA, we're now going to send back to it. With a little luck, this will give us a class ID. And now what I need to do is I need to find what the actual item is. And we do that with net get class description. Get class disk. Net. And I didn't put the dot in there. Net dot get class disk. Okay. And then what do I send it? Well, class ID. And so if what it finds is an item of class 4, now I send this get class description, I send it 4, and then it comes back and tells me it's a teapot or whatever. Okay, so now I should actually know what the item is. And so what I want to do now is I want to go ahead and calculate the frames per second. And so I'm going to calculate a change in time. dt is equal to time dot time. That's what time it is now. That's what time it is now. And I'm going to subtract the time mark I got up above. Okay, the time mark I got up above. And so that's the change in time that is elapsed so far. And then frames per second is equal to 1 over dt. So like if I'm operating at a dt, if the change in time is 1/10 of a second between trips through the loop, then what is the frames per second? It's 1 over the change in time. And so it's a real simple little way to calculate the frames per second. But there typically is a lot of noise in that, so I want to smooth that out with a low pass filter. So I'm going to create a new parameter called frames per second filtered, and I set that up above filtered, and make sure I got the same variable name, frames per second FPS filter. Okay, and that is going to be a low pass filter that I'm going to put on frames per second. So I'm going to keep 0.95, 95% of the old value, which was frames per second filter, and then I'm just going to put on 0.05 or 5% times the new frames per second. And so this will smooth that function out, that frames per second, so it's not jumping all over the place. Now if I'm going to do that, what I'm going to need to do then, I'm going to need to go ahead and grab time mark for the next trip through. So then the next time through I'm really looking at the dt or the elapsed time. So that's time.time. Okay, so dt is going to be how long it takes to go through the loop once. 1 over dt is frames per second. That's good. And then I apply this low pass filter to smooth it out. Okay, now we are ready to show the image. We're ready to show the frame that we grabbed, but what we need to do first is we need to go ahead and we need to put some text on it. And the way we do this is kind of like the OpenCV put text, but here we need to oh, and you know what I didn't do up here? I didn't create a font. So I need to come back up here where I'm doing all of this good stuff. I created my display, but I did not create a font. So I need to do a font is equal to jetson.utils.cuda font with an uppercase F. All right. And then I'll do an open close. And so now I have a font. And so now I can do the equivalent in OpenCV of put text, but here it is going to be font that I just created dot overlay text. And then where do I want to put it? I want to put it on frame. How big is frame? It is width by height. And then what do I want to put on it? What's the text that I want to put? Well, I want to put the string str of, I want to round off my frames per second because I don't want it to be 21.36457. I don't want it to be that long, so I want to round it. And then what do I want to round? Frames per second filter. Okay, and I want to round it to comma 1 decimal spot. Okay, so you see that, frames per second comma 1 decimal spot. So that should put me in pretty good shape. I need to come over here for just a second. Pardon me for just a second as I get this. Okay, so that is going to be the string that is going to be the rounded filtered frames per second. And then I want to go before the last parentheses, and I want to add the string space FPS space. So that's just a label. I'm just taking the string, which is the frames per second, and I'm adding to it, concatenating to it the strings space FPS, frames per second space. Okay, then what I need to do is I need to give it some more things, and so I want to put what it actually is. So I'm going to put the plus. Okay, do I need a plus there? Yeah. So what I also want to label it with, and I don't need that comma. Okay, I'm just putting the string that I'm going to put on there, and I'm building that string. And what do I want to put? I want to put plus item. And that's what it is that I actually found, right? That's what I actually found up here. So I want to add that string to my string. And you guys are going to yell at me because for 1 microsecond you didn't see the screen. Okay, so that's plus item. All right, now there's a couple of other things that I need to put on here. I don't want to get it in the exact corner, so I'm going to come down 5 and I'm going to go over 5 so that the label isn't off the screen. So I'm going to say come down 5 and go over 5 pixels. Okay, and now what I will need to do is I will need to give it a foreground font or a text font. I'm going to say font dot magenta as a color, and then the background color, and I'm going to say font dot blue. So do you see that? Font dot magenta comma font dot blue, and that should work out very nicely if I'm thinking about this right. All right, that should work out very nice. And so then after that last close parentheses, be a little careful with closing your parentheses. That's the last close, and after this FSP filter right here, that is closing the string function, and then this is closing the round function. So make sure that you get all of your parentheses balanced. That's one of the hard things in troubleshooting, is figuring out where you've messed up on that type of thing, and that was quite annoying. Okay, I'll come down here. All right, now we're ready to display. So what is our display call? We called it display. Okay, and then we want to render once. So this is kind of like the CV2 IM show where you're just showing the frame. Display.render once. What do we want to show? Frame. And the frame, we've already put the text on it, and width and height. Okay, so let's run this thing and let's see how many mistakes I made. Okay, just a warning. The first time you run this, it's going to take 5 minutes because it's got to sort of optimize and train and learn and optimize all the parameters for this ImageNet, GoogleNet. And so if you haven't run GoogleNet before, it might take 5 minutes. But I've run it before, so it should just take about 30 seconds for me, I think. Okay. Oh. What is this height not found nonsense? Where is that? Did I misspell height? Oh my goodness. Were you guys screaming at me? Width, W-I-D-T-H. What kind of craziness was that? Width is 1280 and height is 720. I do not understand how I could have made that mistake. Okay, and we will be running here in this call, we will be running on the webcam. Okay, run Python file in terminal. Jetson is not defined. Where is that in line 1? What? I don't know, Nia. I think I might have started that wrong. I hate this. Yeah, you know what? I hope I don't have to just kill this whole thing. There's a kill terminal. Okay, now let me try this again. Run Python file in terminal carefully this time. Looks a little bit happier. Loading up a model. Got some good stuff happening here. Okay, it didn't show. Frames per second filler, I misspelled. So frames per second filter. Let's try that. Hopefully you guys caught that. Frames per second FPS filter. All right, and then let's say run Python file in terminal again. It's thinking about it. Will it work this time? What did it not like that time? Did I misspell it wrong twice? It says, yeah, where I count. Oh, man, is my T not working on my keyboard or something? I think this wireless keyboard is maybe playing tricks on me. So let's try it again. Where are we? We've got some signs of life here. All right. So interesting. We are operating at 10 frames per second, and it sees the green screen behind me, and it sees it as a shower curtain. Okay, look at this. This is really neat. And so 10 frames per second, we're going really fast. And so let me see if I can show it some other items. Okay. And so let's look here, and it sees the computer mouse. Okay. And at 10 frames per second, I'm getting computer mouse. I'm getting computer keyboard. I'm getting space bar. I'm getting punching bag. No, it's a microphone or mic. That looks good. Then here it is seeing it as a monitor. Up here it is seeing my umbrella. If I look over there, it's seeing a desk. Boom! Guys, do you see this? This is pretty incredible for just a few minutes work. Okay, let's look here. But do you notice how I'm trying to give it kind of a clear view of a dominant item? And so that is a pill bottle. Can never have too much vitamin C in these days we're living in right now. And let's see, it sees that as a coffee mug. I really wish that, oh, okay, now it sees it as a coffee pot. I wish that it would see it as a teapot. I would really sort of look at that more as being a teapot. Let's just see, this is kind of a bowl cup type of thing. So it sort of sees that as a coffee pot or coffee mug. So I'd say that's pretty darn good. Let's look here and see if we can give it a nice view of a pen, ballpoint pen. That is looking pretty good. I will show you my shoe, not a very fancy shoe, but it sees it as a loafer. That's pretty good. I kind of show it this, and it's seeing a doormat. No. Okay, it's seeing a sleeping bag. No. Jeans, blue jeans, or denims. Okay, so that's pretty good. All right, man. So this is pretty darn exciting. So you could see a couple of things that we could go in and start playing around with. Now remember, on these we don't cue to quit, we click to quit, we kill the window to quit. All right. All right, so that quit. So we now have that working. Okay, so let's sit and think about what I liked and what I didn't like. What I really liked was how fast it was, how bright it was, but what I didn't like was I didn't like how, notice when we run this thing, run Python file in terminal. I'll run it again. What I don't like is I can set the image size, but the thing makes the window full screen. And so there's no tag. I don't have any tag that would allow me to make the window the size of the image. And this was kind of a silly way of doing it. I mean, they should have sized the window to match the size of the frame in my mind. So I don't like that. Okay, now for you guys that are running on the PyCam, let's uncomment out that. And let's comment out the webcam, and let's see how this thing runs on the PyCam. You guys leave me a comment down below. Who's using the webcam? Who's using the PyCam? Who has both? Because it kind of helps me. Boom. Okay. So now what you can see is it recognizes the microphone. All right, now there are two things that I do not like about this. Okay, there are two things that I don't like about this. I don't like what I like about it is it's running at 23 frames per second. Okay, 23 frames per second, and watch this. Boom. You see no latency at all. 1, 2, 3, 4. So fast, no latency. I don't like the quality of the image compared to the webcam. Did you notice how the webcam had much greater brightness and contrast? And the second thing I don't like about this is that what appears to be happening is it appears to be cropping the image and not just, it appears to be cropping the image and not resizing the image. And let me just try that and see if that's really true. So I'm going to kill this. Well, there's a couple of things I need to do. I'm going to go back to the other one. So that was like 22, 23 frames per second. Let's check and see what the frames per second is on the webcam. Takes a second to get this thing going. Okay, so it takes a second for the filter to come up to speed. Okay, but you can see that we're operating at 10 frames per second with the webcam. But do you see how much higher quality the image is from the webcam? Okay, so let's see that. In fact, it's getting microphone. So 10 frames per second compared to 20 frames per second on the Raspberry Pi camera. All right, so let me kill this. But I really think what is happening on this Raspberry Pi camera is I think that when we are setting it to 1280 by 720 instead of making a 1280 by 720 image, it is cropping the bigger full scale. So rather than scaling it down, it's cropping it. And that could be an issue later on. Okay, so what is the biggest thing that I do not like about this? I do not like that I get this great big window, and that window you can't even resize. So it's sort of like steals your screen, fills it up with a great big window, and then it'll put a smaller image in there. And so I do not like that at all. So we're going to go in and we're going to try to see if we can alter this. We can work with this for a second, and then what we will do is I've got to do a little bit of Windows management here. Okay, okay, so we're going to see what I'd like to do is, you know, the thing about our old friend OpenCV, we could control everything. We had much, much greater control over things, so we could put the text however we wanted. We could draw on the image. We had all of these different tools that we could use, but we just couldn't access these Jetson Inference tools. And so I want to use the Jetson Inference tools because you could see that they were really fast, 10 frames per second on the webcam and 20 frames per second on the Raspberry Pi camera. That's pretty incredible. But you see, the thing is that as far as what I can do with the camera and what I can do with the display, I don't have much control at all. So what my idea is that could I grab it using the Jetson Utilities camera and then do the Jetson Inference like we just did, but then when we display it, go back to OpenCV and display it with OpenCV. And let's see, number one, does it work? And number two, how much performance hit do we take by doing that? Okay, how much performance hit do we take by doing that? Does that sound reasonable? Okay, I think that's a pretty good thing to do. So just remember, webcam was about 10 frames per second. Raspberry Pi camera was over 20 frames per second. So if we are going to use OpenCV, we are going to need to import it up here. So let's come in and let's add import CV2. And then also we will need NumPy because OpenCV uses NumPy. So we're going to import import NumPy as NP. That looks pretty good. Okay, and then we still have width is 1280 and we still have height is 720, and then we still create the cameras the same. We're still setting up this, and now though what we are going to need is that we are not going to be displaying using we're not going to be using GL display, so I'm going to comment that out, and we're not going to be using the font on the display, so I will comment those two things out because we're going to be doing the display side of this thing in OpenCV. At least we're going to see if that will work. So what I will also need to do here is now create the font that OpenCV wants, so I'm going to say font is going to be equal to CV2 dot, and then we will say font underscore Hershey underscore simplex. Okay, and interesting, it seemed like my autocomplete wasn't working again. Remember how we fixed that autocomplete, but it seems like it has ceased to work for at least right now. We'll have to figure out what's going on there. Okay, that looks good. Now still we will get our frame width, height, and we'll do a cam capture, RGBA. But now we're going to be doing some conversions because remember OpenCV later on is going to want BGR and not RGBA, so we're going to have to do some conversions. So I'm going to have to put a command in here, and that command is 0 copy equal 1. And what that's saying is don't be moving that image around into different places in memory, but kind of have like one place that the image is and then reference that one place in memory. And so it's beyond the scope of what I can really fully explain here, but in order for these conversions to work right and for the program to work right, we've got to do a 0 copy equal 1 inside of this camera call. Okay, now we are going to do a class ID and confidence. That's going to stay the same. We're going to figure out what the item is. We're going to figure out what the frames per second is. We're going to get the new time for the next one. And now what we are going to need to do is, let's see, have we done our detection yet? Okay, yeah, so up here we did our detection right off the bat, and then we figured out what the item was. And now when we get down here, we are ready to display it. But instead of displaying, so we're going to not put the text with the Jetson utility, and we're not going to do the display with the Jetson utility. What we're going to do now is we are going to need to convert that frame from the CUDA format, which these Jetson utilities use. We're going to need to convert that over to our OpenCV format. And that's going to take a couple of lines of code. And so we're going to do a conversion where frame is equal to C is equal to Jetson utils. So we're using the Jetson utilities. And what do we want to do? We want to go CUDA, where we are, to NumPy. Okay, so this frame image is in the CUDA format, and we want to go from CUDA to NumPy. All right, so look at that kind of carefully. Lowercase c, and then the T and the N are uppercase. So we're going to convert from CUDA to NumPy. What are we going to convert? Frame. How big is it? Width. How high is it? Height. Okay, and now we got to give a dimension to the array, the NumPy array that we're creating. And remember, there's 4 numbers in this CUDA format: R, G, B, and A. So if we're going to convert, we got to give it a place for that 4th one, for that A. So our array is going to be Jetson utils CUDA to NumPy frame. That's going to be width, height, and a dimension of 4. All right, and so now, where are we? We are probably right now in the NumPy format, but the problem is we're not in CUDA, we're in NumPy. That's good, but we're still in RGBA. So what would we do? We would say frame is going to be equal to CV2 dot, remember our friend CVT color, convert color. Do you remember that one? Okay, what are we going to convert? Frame, and then CV2 dot color. And can you guess where we are going from? We are going from RGBA to BGR. All right. Now there is one other thing that we have to do that you haven't probably seen before. We have to do dot as type, because I believe that the CUDA, those numbers came over as float 32, and NumPy, or OpenCV wants an unsigned int. So we have to do the conversion as type np dot unsigned int 8. And make sure you do this right. UI, and I did it wrong, np.uint8. That's unsigned int 8. All right, so that should now give us our frame in our old friendly OpenCV format of BGR. So now we should be able to show it, okay? And so what I'm going to do is I'm going to put the text on there. So I will go back to cv2.put text, okay, cv2.put text, and I'm going to do frame, and then I'm going to make a string out of, and I'm going to round. This is kind of similar to what we did before. And what do we have? Frames per second filter, got the T in there this time, round it to 1. And so now I have a rounded string of frames per second. I come before the last parenthesis, and I'm going to concatenate to that string, open quote space, FPS for frames per second, and then a couple of spaces. So we want to put in the label FPS for frames per second, leave a little bit of space, and then like we did before, we want to add or concatenate what the item actually is, which we figured out above. And now a comma, and where do we want to put it? Well, we'll put it at 0,30, so that should be roughly in the upper corner, but not off the top of the screen. And then we will want a comma font, which we defined above. a font height, which we'll put as 1. Okay, and then we will be very careful not to cover up what you are looking at there. And let me be very careful, because you guys know I have a lot of trouble with this. I have a lot of trouble with this put text command. So now the size was 1, and now we are going to give it a color, which I'm going to give it 0, 0, 255. And then a comma 2 for weight, and then it looks like it's already closed up all of my parentheses for me, so that looks pretty good right like that. Okay, so now we have put the text, and now we will want to let's see, we put the text. Now I think we are ready to show the frame, so we will do cv2.im show, and then what are we going to show? Our detect, this is our recognize cam, something like that. And then I'm going to show frame, which we have converted into a format hopefully that OpenCV will like, and then do a cv2.move window. And what window do we want to move? Rec cam, and then comma. We're going to put it at 0, 0 as we usually do. Now we got to do all this nonsense. Remember, if cv2.wait key for 1 millisecond, if that is equal to the value of ord, not org, ord of q. So that means if we press q, then we want to break out of this whole while loop. And then what do we want to do when we break out of the while loop? We want to do a cam.release. Okay, like that, cam.release. And then we want to destroy all windows. So we will do a cv2.destroy all windows, like that. All right. That's a lot of typing, and I have no idea how many mistakes I made in there. But this should do the same thing as the last program, only it's allowing us to display it in our own window that we have better control of. So let's run this thing and see how many mistakes we made along the way. Have you guys been screaming at me? All right, what is going on? Need to check here and see if I can look and see what happened. Okay, display is not defined. Where did I use display? What line? If we're going to do, if we're not going to be using the display, we never created a display, so we've got to go back to the old tried and true while true. Okay, that makes sense. Let's try it again. Got a lot of stuff going on here. Whoa, look at that. I've got something going on here. Okay, so look at that. Boom. Kind of blurry, all right, but this is the webcam. Note, I am operating at 10 frames per second. We've done this, and we haven't taken any performance hit. All right, we still have a really clear webcam image. That makes me happy. We're still operating at 10 frames per second. That makes me happy. We're still recognizing things. That makes me happy. And so this is just super, super successful. So let me go ahead and quit out of this. And before we celebrate too much, let's go try our old trusty Raspberry Pi camera. And so I'm going to create the Raspberry Pi camera. But if we are going to create the Raspberry Pi camera, I hope I had both of those. Oh, yeah. So we're going to try the Raspberry Pi camera. So I will need to comment that out. And then this should give me the Raspberry Pi camera, and we'll see what happens. All right. Looking good so far. Okay, boom. Boom, you see that? All right. So, operating at 20 frames per second. All right. And let's check the latency. 1, 2, 3, 4, 5. No latency, right? No latency. And we have got the full frames per second that we had a while ago. So that is really cool. That is really cool. And that is working. Okay. So let's see where we are in our introduction to machine learning, deep learning, and deep neural networks. We have our first program up and going, and we've gone beyond the basic NVIDIA package where they kind of gave us a way to show our rendered image without any ability to control it at all. And we have kind of taken the best of the Jetson utilities and the Jetson Inference, and then we've added to it the things that we have more flexibility with our old friend OpenCV, and we didn't pay any FPS price for that. So that was a pretty good move, a pretty smart move. And remember, no latency as we were doing that. There was no latency at all. And so the question would be, why don't we just stop there? Okay, and I will show you the thing that I don't like. On the webcam, we can set the size, and that's really about all we need to do, and that's really about all we can do in GStreamer when we were doing things the other way with OpenCV. But let me show you what I don't like. Let's go back to the webcam, or to the Raspberry Pi camera, which I believe we're on here. Takes a second to load. Here we go. I think it's going to work. Boom. All right. Now, I like it that I'm getting 20 frames per second. I like it that there's no latency. 1, 2, 3, 4, 5. I like those things, that there's no latency, and I'm getting 20 frames per second. This is what I don't like, is that on this image, when I told it that I wanted it 1280 by 720, the way that that Jetson utility, that GST camera launches GStreamer, it's kind of like they did it wrong, because the way they put that width in there, they just took the whole image and they cropped it. And in fact, I don't know if this would run, but if I made it even smaller, let's see, this might, it probably won't work, but if I made it smaller, it would just crop more and more, so it's not resizing the image, which you really want to do. I'm going to say I think it's a bug in the way that they launched their GStreamer command inside of that GST, what was it? That GST camera command. I think they have an error in there. And what that does is that kind of locks us out. The other thing I don't like is they didn't give us any real handles on that GStreamer pipeline. And so if you looked at that picture, it was kind of washed out. And because I got the fluorescent lights, it was kind of washed out and blue. But I don't have any ability to put parameters in there that would make it better. All right. So what would you think that maybe we could do? What if we use the camera from OpenCV, right? What if we use the camera from OpenCV, converted it to CUDA and RGBA, then did the inference, the deep neural networking, artificial intelligent deep learning kind of business, and then converted back to show? what price would we pay in our frames per second, and would it really work? So it worked what we tried the first time. Let's see if we can go one step further and see what will happen. So we will come over here, and I need to do a little bit of Windows management. All right, that looks pretty good. And we're going to come in here and we are going to do some new stuff. So we still have Jetson Inference, we still have Jetson Utilities, CV2, NumPy, and Time. I think that's what we need. We need width and we need height. And now, since we're going to launch the camera using our own GStreamer command, at least for the Raspberry Pi camera, what I need to do is I need to go ahead and tell it flip equal to. And then we've got to get that GStreamer command. And so we can come over here to a browser. And I hate this where it decides to resize it for me. I know there's a way somewhere you can turn that off, but I don't want to do it right now. Okay, so we are going to come over here and we are going to go to Top Tech Boy, www.toptechboy.com. And most of you guys that have been playing along know that you can just get it from one of your old programs. But I think if I just search on Nano Camera, this looks like it. And there's that one line of code, and rather than me trying to type it, I'm going to come and get it. It is this cam set. So I'm going to select that whole line, and I'm going to copy it, and I'm going to come over here, and I'm going to paste it. And so that is our old friend, the GStreamer string that will launch a good Raspberry Pi camera. Okay, now I am not going to create the camera using the Jetson utilities. Okay, and I'm going to have two different ones here. I could say that cam1 is equal to cv2.video capture, okay, of what? Of cam set. All right, so that would launch the camera. Or the other way I could do it would be to say cam1 is equal to cv2.video capture, and then I believe that we do /dev/video1. I do believe that's the way we do it, if I'm not mistaken, if we wanted to get a webcam. But I'm going to comment that one out, and we will be going with the Raspberry Pi camera for this first time. Okay, so that sets the camera. Now we still need the Google Net. We still need the frames per second. We still need to grab a time, and we still need a font. Okay, now what we're going to do is we're still going to be doing while true. All right, but we're not going to be grabbing a frame that way, and we are going to have to grab the frame using our old friend, returns two parameters, so underscore, comma, frame, and it is going to be equal to cv2.video capture. All right, cv2.video capture, and then what do I capture? Oh no. What am I thinking? CV, it's my camera, cam1.read. Okay, like that. And we're reading that into frame. Okay, now what I want to do is from frame, I'm going to keep frame because I'll use it, but I'm going to create img, and that's going to be equal to cv2.cvt color. Okay, cvt color, convert color, and what do I want to convert? Frame. And what do I want to convert it to? cv2 dot, do you remember? What would you guess? Color underscore what? BGR to RGBA. All right, because the inference tools want RGBA. So now I'm in RGBA, which is good. Okay, but now remember how I had to convert it to an unsigned int 8? Well, similarly here, I have to go backwards and I have to do this as type, but this wants NP float 32, numpy float 32. So it's reading this time from the camera an unsigned int 8, and I got to convert it to what the inference tools want, which is a float 32. So we've got that. Now, the problem is we've got a great numpy array in the right format, but the inference tools want a CUDA array. So now I've got to make image to be equal to jetson.utils, and this time we're going to go to CUDA from numpy, kind of opposite what we did before of what? IMG. So we're going to grab a frame, we're going to convert it to something we call image, which is going to convert the color and the type of number in the array, and now we're going to make it a CUDA array. So with those two conversions, we then are ready to do our class ID. We're ready to figure out what the item is. And I think after this, everything else should be the same. So this time, we're going to grab a BGR and then we're going to convert it, and then we're going to convert it back. But actually, you know what? We can make this a little bit simpler because we saved frame up here, so we don't have to convert back. Because we can use image, to do our, and in fact I think we should use image, right? Yeah, this class ID, we can't use frame because that's the wrong format. We have to use IMG. Okay, so we get the class ID from IMG, and then the item is the class description. That's the same. Okay. And then down here, though, after we figure out what is in the picture, we don't have to convert back because we still have our original frame, right? I created a new image, IMG, but we still have our original frame, so I don't have to go backwards here. So I can comment that and comment that. And now when I say cv2.putText, it is still using the original frame. So I'm kind of going down with the original frame and the converted frame IMG, if that makes sense. Let's see what happens here. This is going to be a wild ride. All right. Oh, display width is, oh, okay, yeah. So remember how this GStreamer string wants display width and display height. And so what I need to just do is I just need to say display width is equal to width and display height is equal to height. And now I have these two numbers that are used in that string rather than try to go in and change that string that we've had all this time. I think that will fix that problem anyway. A lot going on there. Seems to kind of hung. That's awkward. That's awkward. I wonder, it's not giving us an error though, so it's kind of hard to see. My friend, it is frozen dead. At least the mouse is working now. Okay. Wow. Is it still trying to go? Ah, look at that. It actually worked. Wow. I was fixing to try to kill it. Okay. So what do I like? I like that I'm at 15 frames per second. I like that I created it. And do you see how now it's not cropping it anymore? But what do I not like? 1, 2, 3, 4, 5. I got like a 2-second latency in there. Okay, I have a 2-second latency. And so let me quit that if I can. All right. Great thing is the program ran. The bad thing is I had a 2-second latency. Let me see if I comment out this. I want to comment out this. All right. And I want to uncomment out this. Let's see if on the webcam what happens. Ooh. Video capture. What did I do wrong there? Silly me. That's an uppercase V. All right. Did you guys catch that? All right. Let's go. I'm not sure why this way takes so long to fire it up. Oh. Line 28, it doesn't like classifying the image. I wonder if it doesn't like it, if it doesn't see anything. I wonder if we should give it something like if it didn't find anything, then maybe item doesn't have a description. What if we say item equal like that, just in case that was a problem? I don't think that would be it, but I'm not sure why it would work with one camera and not work with the other one. Is there anything else that we would need to do? We are not giving, I think I know what we're not doing. We are not setting, this is just a random dimension. So I think that we're going to have to, set that to something, yeah. So let's see if I can do this on the fly, or let me see if I can find a different program here in which I have done this. Let's see if I think it's these things here that I need. And don't worry, I'll show you how to do it. But you see, this is what happened in this. This is what happened in this program. We went out and we turned on the video, but it doesn't know what the display width and the display height are, because that's not a parameter. At least I'm not aware that that's a parameter when you're doing a CV2 video capture of a webcam. So what we need to do is we need to go in and set those, okay? And we're going to set those to display width and display height, which we have up here. Now they should know what the display width and display height is, and then they should know what width and height are, and then when we send this command, those actually have real numbers in them. So let's run this thing now and see what happens. I really think that's going to fix it. Boom! All right. Look at that. Okay, so look at this. We are operating at 10 frames per second. We launch the camera with our own parameters, and let's see, 1, 2, 3, 4, 5. No latency. All right. So guys, let's kind of think about where we are here in this crazy world. Got to quit out of this. Okay, we have made a lot of progress today, right? We've done our first real kind of hardcore artificial intelligence using deep learning and machine learning and a deep neural network. And we were using the most excellent Google Net, I believe. We were using the most excellent Google Net as our detection model, and that worked very well. You guys, again, can go in and you can play around with these other ones. Okay, that, like, for instance, if I just type in AlexNet, and it's this center column that you want to use, those words, okay, I can come in and I can come up to my model here, and I can change it to the AlexNet. And it's going to take a long time this time because I haven't run AlexNet before, so it's going to go in and do that TensorRT, optimization, I do believe, and so it might take a few minutes. No, it didn't. Okay, so let's look at that. Let's see if it still finds the things that it found before. Found the keyboard, spacebar. It's having a little more trouble with the microphone. Okay, so you see this is actually good because you can see that it's not the same as the GoogleNet. The GoogleNet did great on the microphone, and the AlexNet thinks the microphone is a barber chair. Okay, we've got the mouse. Let's see how it does on a pen. Ballpoint pen. Okay, so you can see some similarities and you can see some differences. It recognizes the monitor. Let me see here. Kind of interesting thing that you can do sometimes. Like if I come up here. Okay. This one doesn't. Some of it recognizes it as a monitor. I think GoogleNet might actually recognize, if you look closer there, it might recognize it as a website itself. Okay, doesn't recognize it as a website, but again, that's the difference between the different detection models. We'll leave it on the happy little pill bottle. Yeah, there it goes. Got the pill bottle. So you guys can play around with the different models, see which one you like the best. Okay, because we downloaded them all. Now, what do I like now? I like that I have control of the camera, and I like that I have control of the display, and I like that I have access to the Jetson Inference tools, the Jetson tools for doing the image recognition and in future lessons, the object detection. And what I didn't like about the Jetson utilities is it's kind of like launch the camera and show it and live with what you got. It didn't give me any ability really to control parameters in the way that I can in OpenCV. And so what I like is I like the fact that I'm taking the best of both worlds, the flexibility and power of OpenCV combined with the raw horsepower of the Jetson Inference tool sets. Okay, but now, what was the one thing still that we don't like? What we still don't like is that for whatever reason, something goes very, very wrong when we try to use the Raspberry Pi camera. Let's go back and look at that again by uncommenting out that and then commenting out these. Okay, let's go back and run that Raspberry Pi camera. We got to figure out where are we going moving forward as we're doing more development to give us the maximum power, the maximum frames per second, and the maximum flexibility. And so we got to kind of think of what our options are. What's really clear is displaying it in OpenCV really works, and it gives us complete flexibility to do things just the way that we want to. So that is definitely the way to go. But we still have a little bit of an issue as far as how we're going to grab the frame from the camera. And like I say, I don't know why this almost freezes up when I'm trying to run it on the Raspberry Pi camera. But we'll give it a second. Okay, it looks like it's going to go. Okay, there it is. All right, so now watch this. You see, I've got that 2 frame per second. I've got that 2 second latency in there, and I got good frames per second, but I've got latency that is unacceptable. And so what it appears is, that it must probably, because we know everything else is working, that it must be doing this conversion when I'm doing a conversion. Well, this conversion certainly isn't going to likely create a problem. But when we do this conversion, this CUDA from NumPy, something in there is balling up, and then you end up with a latency, and that latency is just really, really not acceptable. And so what I think the best solution, really, the solution where I was using the Jetson utilities as the camera, that worked good for both cameras, except for it had messed up that GStreamer. It had messed up that GStreamer command for the Raspberry Pi camera, and therefore the Raspberry Pi camera was not behaving like we wanted to. And so what we're going to do in the next lesson, in the next week, we're going to go in and we're going to edit that library, because there's an error in it. Well, maybe error is a wrong way of saying it, but there is a poor implementation, not thinking about that GStreamer command correctly. We're going to go in and fix that GStreamer command for the Raspberry Pi camera, recompile the program, and then we'll have something that actually works. But what your homework is for next week is to play around with these different libraries, these different models, and see which one you like the best, and then just make some comments down below about what you observed as far as which one seemed to work the best, differences that you saw, similarities that you saw. Okay, guys, I hope you haven't thought this is too long of a lesson. I thought it was kind of exciting because we're really starting to get some major new horsepower in our artificial intelligence capabilities. Okay, guys, this is Paul McWhorter. If you like this video, give us a thumbs up. Think about subscribing to the channel. Think about sharing this with other people. Let's see if we can get some more people working on this exciting world of artificial intelligence. So this is Paul McWhorter, and I will talk to you guys later.